our last example is going to be a little bit more complicated. Of course, right? That's how last examples always work. Okay, I'm going to pen and roller support it again. So here's my pen at A. I'll put my roller at B way over here. Alright, I'm going to put a moment on here of 250 pound-feet, not pounds per feet, I apologize, pound-feet. Okay, we'll have that, goes to there, goes to there. £20 per feet URB. And let's get some distances on here. 6 feet, 6 feet, 15 feet, 6 feet. All right, find the equation for the elastic curve. First up in our solution will be the reactions at A and B, and I've of course already solved for those, and I get AY as 210.37 pounds and BY as 149.63 pounds, and AX is still 0 because I don't have anything acting in the horizontal direction. All right, using our singularity functions, working from left to right, so I'm going to set my ordinate here, X and little v, vertical deviation. My moment equation is going to equal to my moment, that's counterclockwise, so that is minus 250, x minus 0 to the 0, and then I run into my point load plus 210.37 times x minus 6 to the first power, and then I start my triangular distributed load, which will be minus, because it's pointing down, the slope, rise over run, 20 over 6, divided by 6 times x minus 6 cubed. Now, the thing with these singularity functions is they have a single function. Gee, I wonder why they named it the way they did. And that is to start the load. Okay, so I haven't gone back up to the table, but I will now. So coming back up here, we've got the triangular one that we used, we've got the point load, and we've got the moment. Okay, once the triangle stops, you'll see here, or starts, there's no way to stop it. So that's what we need to consider now, is stopping this triangular load. It's coming all the way back down here, okay? This thing is going to go on and on and on and on, right? Until we get to B. So we need to remove it. So here's my thought, okay? The triangular load also starts at 0. So I can take this portion up here and subtract that out, okay? So that'll leave me with this, okay? And then we will have to subtract out this little part here. And I'm saying subtract out, but it's already acting in the negative direction. So we're actually going to add, because that would be the opposite of negative, right? Just replay that 5 or 6 times and eventually it'll make sense. Okay, so I need to subtract out the top blue triangular part. So sticking with blue, that is going to be plus, it's got the same slope, 20 over 6 divided by 6. And remember, we're adding because it's already pointing down, so we want to point up to get rid of it. X minus 12, because it's going to start at 12 from the far left, cubed, okay? And then we want to subtract out that last rectangle of green space, so that'll be plus 20 over 2, so that's my W over 2 times x minus 27 squared. All right, and then my very last component will be the plus 149.63 times x minus 33 to the first power. But remember, that's always going to equal 0 because x will never be greater than 33. Okay, it'll always be equal to or less than. So this will go to 0, so we can ignore it for the rest of our universe. All right? So there is our moment equation. So now I need to integrate twice to get my slope and deflection. Theta EI is equal to negative 250 times x minus 0 to the first power plus 210.37 divided by 2 times x minus 6 to the second power minus, okay, 20 divided by 6 simplifies a little bit to 5/9 divided by 6 times 4, 24 times x minus 6 to the fourth plus 5/9 divided by 24 times x minus 12 to the fourth plus, let's see, 20 over 2 is 10, 10 divided by 3, x minus 27 cubed plus my constant of integration 1. 20 divided by 6 is 5/9. So this should just be 4, as should this one. I overthought myself. Okay, so that's 20 divided by 36. That simplifies to 5/9. That's what we divide by 4. Moving on, VEI is equal to negative 250 divided by 2 times x minus 0 squared plus 210.37 divided by 6 times x minus 6 cubed minus 5/9 divided by 4 times 5, which is 20, x minus 6 to the fifth plus 5/9 divided by 20, x minus 12, 5 plus 10/3 divided by 4, so that's 10/12, x minus 27 to the fourth plus C1x plus C2. Ooh, got it all crammed in there. Okay. I'm going to circle this whole thing and make note to myself. That is equal to 5/9. There, I feel better now. Now that I have that, we move to boundary conditions. And I've got a pen and a roller. So at pin A, V is equal to 0, and roller B, V is equal to 0. Pin A is at x is equal to 6. Roller B is at x is equal to 33. And we're in feet. I'm being lazy and not writing my units. All right. So that is going to be, using my huge vertical deviation equation here, elastic curve equation, 0 is equal to negative 250 divided by 2 times, and we're in normal parentheses now, okay, 6 minus 0 squared plus 210.37 divided by 6 times 6 minus 6, so this whole thing is 0, That means this next one is 0, as is this next one, and this next one, plus C1 times 6 plus C2. And then I will have my roller equation. So the roller is equal to 0 at 33. So everybody gets to play with this one. 250 divided by 2 times 33 minus 0 squared plus 210.37 divided by 6 times 33 minus 6 cubed minus 5/9 over 20 times 33 minus 6 to the 5th plus 5/9 over 20 times 33 minus 12 to the 5th plus 10/12 of 33 minus 27 to the 4th plus C1 times 33 plus C2. Okay. I've done a little bit of footwork, and what I get, let's call you equation 1 and this one equation 2. For equation 1, I get it to simplify to 4,500 is equal to 6C1 plus C2. And for equation 2, I reduce that down to negative, let's see, what is that number? 268,726.5, and that's equal to 33C1 plus C2. Solving for simultaneous equation, whatever your preferred method of destruction is there, we find that C1 is equal to negative 10,119.5, and C2 is equal to 65,217.7. So our final answer will be the vertical deviation EI is equal to negative 125 times x minus 0 squared plus 210 divided by 6, that's 35.1 times x minus 6 cubed minus 5 over 100 times x minus 6 to the 5th plus 5 over 180 times x minus 12 to the 5th plus 5/6 of x minus 27 to the 4th minus, whoa, I apologize, 10100 x plus 65200, and this will be in pound feet cubed.